fifth experiment is designed to answer the research question, what is the optimal isolation material for a domestic home? So here we built a small wooden domestic home, as you can see, with a flat rooftop. And here on the rooftop we can use different isolation materials. So we have the styrofoam, we have the hard foam, and we have the cork. And now we want to heat up this house and see how much of this heat inside the house comes to the outside of the house. Inside here we use a normal light bulb, and yes, it produces light, but it also produces heat because it has a wire inside which glows, and therefore it produces light but as well heat. So it's a 75-watt light bulb. So now we can put the first isolation material on top of the roof of the house to measure the heat transfer disappearing from the inside of the house to the outside. So if I do measure now the surface temperature, we do have 29 degrees. And if we measure the room temperature here, we have only 26. So we've got already a difference of 3 degrees from this styrofoam to the outside temperature. Now we'll wait a bit, and then we can measure again to see if the heat disappears from the house through the isolation material. Now we are already at 34 degrees. So the temperature is rising on the outside surface here of the isolation material very quickly. Now we can check another one, maybe the cork. We do have 27 degrees in the moment, and we can wait again. So now if you say this experiment is not suitable for me because I don't teach civil construction, I don't have people who building houses, but maybe you are from the plumbing department and you need to cover heat pipes. You can use this experiment as well, either with the setup here, or you change the setup that you have like a pipe where you have hot water inside and you use different heat pipe covers and you measure the outside temperature after a specific time to see which one is the best for you. Now let us measure here again. We have 27 degrees. So the temperature is nearly not increasing here on the outside surface of the cork. It still feels the same like here in the room. So this one looks better than the first one we tested. Now if we're coming to experimenting, we must say we need a controlled condition, meaning if we put this one down and we measure already after 5 seconds and the next one we take and we measure after 10 minutes, it makes a huge difference because the heat has way more time to disappear from the house over the heat transfer through the isolation material. So we need to actually stopwatch the time to see that we make measurements always at the same spot of time. And if we leave this house open too long, you see all the heat can disappear here. So maybe we should check the inside temperature as well. And therefore we have a multimeter, and that multimeter has a temperature sensor which we can use. So we can push this one inside here through the hole at the bottom, or we'll put it in on the top here. Could hang it inside here, but I push it inside the house through the hole at the bottom. So now we do have a temperature sensor inside the house, and we can connect it to our multimeter, go onto the temperature setting, and now we see it's 37 degrees inside the house. Now if we cover the house, let us see if the temperature rises. 40 already, 41 and 42. So the temperature is rising already because the heat can't disappear anymore through the open roof of the house. So if you want to have a controlled condition, you should check all these variables so that you have only one variable which is dependent and one which is independent. So the independent variable is here, our isolation material. We change it. So we have 3 variables which are independent, and the dependent variable is the temperature here outside on the isolation material. So how much heat is transferred through the isolation material. So as a learning objective for your learners, it's not only about the isolation material, but you can also teach them how to do an experiment, how to conduct it, how to plan it, how to go through it, and how to evaluate later on the data you collected. So you collected different measurements, and then you need to come to a final conclusion and decision. And if you consider as well cost of the material, maybe weight, because this one is far heavier than this one. So if you want to have it on your rooftop of your domestic home, it also might play a role which material to choose. So as you see, you have a couple of possibilities to include this experiment into your lesson, and it doesn't have to be only civil engineering. It can also be plumbing or engineering science, where you look into heat transfer, isolation materials, measurements, how to conduct an experiment, a couple of possibilities to use this experiment. Now I said this is the 5th experiment, meaning we have some others as well. So down below in the description you can check out our YouTube channel, the playlist, and also our website, where we provide all the data for this experiments. So you can download the worksheets and the drawings and everything you need to rebuild this experiments yourself. So you might ask, okay, what does it cost to build this? The most expensive parts are the multimeter and the infrared thermometer. So this one costs around 25 euros, which is around 500 South African rand. This one is around 20 euros, which is around 400 South African rand. So these are the most expensive ones. If you have a multimeter already with a thermometer sensor, then you are sorted. This one you might not have. You need to buy that one. And the rest of the house, the wooden part and the isolation materials, are around 20 euros, 400 South African rand. So in total, if you take everything together, you are around 65 euros, which is 1,300 South African rand, roughly. So yeah, feel free to rebuild and use it in your lesson, and we would be very glad to see someday some pictures from you, maybe on your YouTube channel, how you adapted this experiment and used it in your own educational context.